Okay, the second talk is about differential linear cryptanalysis of reduced round Cha-Cha, given by Jichao Xu, Hong Xu, Lin Tang, and Wenfeng Qi. So the speaker is Lin Tang. So please give your talk.
Thank you. Hello, everyone. I'm Lin Tang. I'm very glad to share our work about differential linear cryptanalysis on round-reduced Cha-Cha. This is in joint work with Zichao Xu, Hong Xu, Wenfeng Qi. First, let's recall the background. The stream cipher Cha-Cha is introduced by Weston in 2008, which is applied by many protocols on the software, such as TLS, SH, and so on. The input X is a matrix consists of key and constants and IV. The first row is the constant. The middle two rows is the key, and the last row is the IV vector. And the round function of Cha-Cha consists of 4 QR functions. The QR function is as the figure 1. For all the rounds, the QR function is applied to equal columns. For even rounds, the QR function is applied to each dialogues. The key stream C is the sum of X, the input X, and the output of R round function. The fictional linear cryptanalysis was proposed by Langford and Hessam in 1994, which has been widely used to attack many ciphers. For a given input difference, delta in and out linear and master gamma out of a cipher E, the correlation C of the differential linear distinguish is defined by this formula. The cipher E can be distinguished from the permutation with about O C to minus 2 plus. Let's introduce PNB-based key recovery. This technology includes 2 stages. The first stage is a pre-processing stage. We found a R-round differential linear distinguish. Then we select the PNBs by threshold gamma constant paths such that the SKB is changed. We consider the correlation in gamma I. When gamma I is bigger than gamma, the SKB is selected as a PNB, otherwise is not a PNB. For the online stage, we guess public key bits, the values of the long PNBs, and compute the path for the correlation. When the key bits is guessed correctly, we will get the correlation is this. Otherwise, the correlation is 0. We will look less about the assignments for PNBs. Usually, the assignments for PNBs are all zeros or random values. But it was found by D for a set of cultivate PNBs. The assignment 1000 can provide a better correlation. This is the complexity of the PNB-based key recovery. The time complexity. This. This table gives an overview of the differential linear attacked on 7 round, 7.25 round and 7.5 plus round for Cha-Cha. At FSE 2023, Berlin found a 4-round differential linear distinguish with the correlation 22 minus 3, 4.15. They use 116 PNB bits for 7-round Cha-Cha. Our motivation. The first one is how to improve the correlation of the differential linear distinguish. The second one is can we improve the number of the PNBs? The second one, use the better assignments for PNBs. We can improve the background correlations. So we use the differential linear Haar method. The correlation is improved by 2 to the power of 1.95. Second, we process an algorithm to search more PNBs. Then we use the better 1000 assignments for PNBs. We got a better correlation. And finally, we give a proof on the security requirement of the reduced round Cha-Cha. Now I introduce our tech on 7 round and 7.25 round Cha-Cha. For the FSE, there is a differential linear distinguish for EE1 with the correlation R and a linear approximation of E2 with the correlation Q. Then we got the correlation RQO22. If we have a multiplier choice, we can get the differential linear Haar effect. That is, we can get the total correlation is the same of them. At the FSE 2026, Berlin found a 4-round differential linear distinguish as follows. This is 2-round differential linear distinguish and 2-round linear approximations. The correlation is 2 to minus 34.15. We use a tool, SAT, to search more linear approximations, the gamma 3 to gamma 5. We found 16 trails. Of them, there are 4 trails with the correlation is about 2 to minus 2 in this table. And another 14 trails with the correlation 2 to minus 3. For the first part, we use the similar method as Berlin to evaluation the correlation by experiments. This table shows our results about the 13 trails. We got the correlation with the sum of the net trails. We got a gain of 2 to the power of 1.95 compared with the result of FSE 2026. Next, we give the attack on the round reduced Cha-Cha. The round reduced Cha-Cha is divided 3 parts. The E covered 1 round, EM covered 4 rounds, and E2 covers the 2 or 2 to 25 rounds. We proposed algorithms to search more PNBs. In these algorithms, we set two thresholds, gamma and gamma prime. For the first step, we choose the key bits I when the gamma I is bigger than gamma, and when the gamma I is bigger than gamma prime, but gamma I is smaller than gamma, we choose it as a candidate PNBs. In the second step, the PNBs are selected one by one with the greedy algorithm. As a result, for 7-round cha-cha, we found 169 PNBs, which is more 9 bits than the result at FSE 2026. We also use 1000 assignments. We got a correlation to the point of the power of minus 11.855. Now this is the complexity of our attack. The time complexity is 2 to 189.7, which improves the previously attack by 2 to the power of 17.1. Similarly, attack to 7.25 round cha-cha. By our algorithms, we got the PNBs 133. The number is similar as the result, the number at FSE 2026, but the setter is different. We also use 100 assignments. We got a better correlation. This is the complexity of attack on 7.25 rounds. Finally, we give a proof on the security about the equivalence round reduced cha-cha. We proved the equivalence is security between R plus the 0.25 rounds and R plus the 0.5 plus rounds. The reason is in the last two lists, the modular addition can be exchanged. This is the picture. 7.25 rounds. This picture is 7.5 plus round. So we give the equivalence security against the choose or known plane attacks between R plus the 0.25 rounds and the R plus the 0.5 plus rounds. Finally, I give a conclusion. Based on the differential linear Haar method, effective search algorithm, and better assignments for PNBs, the correlations of the differential linear distinguishing and the correlation are increased. Based on our distinguishes, we give improved attacks on 7 round and 7.25 round cha-cha. Finally, we give a proof on equivalent security between R plus the 0.25 round and R plus the 0.5 plus round of cha-cha. That's all. Thank you for your attention.
Thank you for your nice talk. So, are there any questions? Please.
Thank you for the talk. When we combine two different techniques like differential linear, the theory sometimes does not match the practice. So when we do the experiments, the biases or distinguishers and attacks for Cha-Cha. So did you experimentally verify your improvements, or they are just theoretical results?
Experiment?
Did you do experiments to see if the improvements you obtained in the correlations are really observed in practice?
Yes, we compute the correlation of the backward correlation by experiments and use the similar method as a bilinear. We use 2 to the power of 48 samples to evaluate the correlation by experiments.
Yeah.
They see the number of the samples is bigger than the correlations to -2.
Thank you.
Thank you. Thank you, Chrissy.
Are there any questions? Oh, please, Yosuke.
Thank you very much for talk. So for PNB, so you have 3 cases. So yes, here. So for the assignment, you have all 0 or 1, 0 stars. So so when you use the case 2, so did you assign 1, 0 star for everywhere, or you choose a 1, 0 star or 0 or 0? So ad hoc, or I'm not so sure. So which did you use?
This procedure was proposed by Day in 2026 in IEEE TIT. 100 is assigned to consecutive PMBs. So we use the same method of the assignments. This is the case 2. Case 2 is use the method of 100. We got use the same PMBs as FSE 26. The correlation is better than FSE 26. Use our algorithm. I got more PMBs, 169 PMBs. We use the same method of assignment for PMBs, like days.
Okay.
Thank you.
Okay, it's time to end this session. So let's thank the speaker again.